TGIF. Thank God it's Friday. Right, so today we're going to continue or finish up, wrap up for this week on length of an arc. On Tuesday, we did the circumference. On Wednesday, we did area of an arc. Yesterday, Thursday, we looked at the area of a sector. And today, we're going to look at how to calculate the length of an arc. So, what's our objective? Calculating the length of an arc of a circle. So, what is an arc? Simply put, an arc is any part of the circumference or any extracted part from the circumference. So, similarly or typically, this is what we have here. AB is known as an arc because it's just part of the circumference. And remember, on Tuesday when we discussed what is the circumference, we look at that as the total distance around the shape. So the arc will just be a part of the total circumference. So if I take out a part of the circumference in a circle, I have an arc. And here we have another example. Just like when we did with the sector, remember, we have a minor arc and we have a major arc. And the minor arc simply means that it's a smaller piece from the major one. The major is a bigger arc. The minor is a big piece, like the big boy. Major. Good. The formulas, again, pretty straightforward. Just yesterday we looked at theta over 360 times the area of a circle, which is pi r squared, because we were dealing with the area of a sector. But now we're dealing with a length. So it's kind of natural to see that, okay, length deals with circumference. So we have 2 pi r or pi d. Because remember, when we're calculating the circumference, we have two options. We could say 2 pi r is equal to the circumference or pi d. And now we're just multiplying that by theta over 360 because we're looking at an arc. So we have a fraction of the circle. And that's all that is happening here. Sorry. So here we have a perfect example. They want us to calculate the length of HK. And everything we need is there. Of course, they didn't tell us what is pi. And that's all I need because I didn't put them. So in this one, I'll use pi as, which one? It doesn't matter. Let me use pi in this one as 3.142. It actually doesn't matter. Anything you use is supposed to get the same thing. Although 22 and 7 is more accurate because it's a fraction. So all values will be included. Sorry about that. Oh my, I'm tired. Right. So here we have length. So HK here will be equal to theta over 360 multiplied by 2 pi r, which is equal to theta here is equal to 100 degrees. So that will be 100 over 360 times 2 times 3.142 as pi times r, which in this case is 6. It's always actually wise to have pinpoint your values. So we know theta, we know r. So I should have written r here as 6 cm because those are given information. And from here it's just a matter of computing. So here I'm using my calculator. So I have 100 times 2 times 3.142 times 6. And that's that. Hold on, I did something wrong here. Oh no, I didn't. It's a fraction. And then I divide that answer there by 360. And according to my calculator here, I am getting a length of 10.5 cm. So this here will be the length of HK. So H all the way to K here. I wish I could have made that line more smooth, but that's the length of that piece there. So here we have two examples again. Let us try and do some. But in these two, of course, you could pause it here, give it a try, and then you could see them, you could compare them with mine. I'm not speaking. So let's go back. So they want us now to calculate the length of an arc when the diameter is 14 and the included angle is 80. So in this one, we're given the diameter. So the diameter is 14 meters. So we could use the second formula. And we know that theta in this case would be 80 degrees. And since we're not given pi, the choice is on me. So I would use 22 over 7. more accuracy. And then I say the formula. So let's call this length AB. Let's say AB is equal to theta over 360, and I'm multiplying that by, oh, let me use pi d because we got the diameter. So let's use pi d. You could still use 2 pi r, because in this case, if you know the diameter is 14, then the radius will simply be half of that, which is 7. But it will still come back to 14. So let's substitute our values. So now we have 80 divided by 360 times, I choose to use pi in this one as 22 over 7, and that will be multiplied by 14 over 1. And note, when you're doing your maths, oftentimes I will tell you what to use as pi. So don't make a headache out of it. Don't decide to make a problem out of it. They will tell you. And if they don't tell you, then that simply means that it is open. The choice is yours. And when I work out this one, I was working out while I was talking there, and I got 9.8, and it goes down. So this is correct to one set decimal place. So this is 1.8, 1 dp. Good. And again, even this, they will usually tell you how many decimal places you have to round it off to. So if they don't tell you, then you use your discretion. But if they tell you, you have to follow those instructions. Bear that in mind. I trust you got that answer. Let's try the second one. So here they give us the radius. So they told us that the radius is 10 millimeter. They give us theta. Theta here is 190. 190, and I'm going to write 120. 190 degrees. And they didn't give us pi as usual. So I would use it again as 22 over 7. It's the easier one to use. Once I'm dealing with fractions, it's easier to deal with this pi. And we go again. Let's call this length here ST. We just give it a name. And that is theta over 360 times. We have the radius here, so let's use 2 pi r, which is the same as this is 190 over 360 multiplied by, let's say, 2 over 1 times 22 over 7, which is pi, times 10 over 1, which is our radius. So I just make everybody look like a fraction, so it will be easier to compute, or it might seem more, how should I say, parallel, I guess, that's the word I'm looking for. It will look more parallel when you have everybody as a fraction. So like you just deal with the denominator, and then you deal with the numerator. You deal with the numerator, and then you deal with the denominator. Either one is the same thing. And here, the length would end up being 33.2 millimeters. And this is our correct to one decimal place. And notice also, I guess I should say, just in case, for me something that is for obvious, but for many they may not see. Notice in this case, we have the units are not squared, and that's perfectly fine, because remember, we are calculating a length. So there's no need to square the unit. You just have to state the unit because it's like you're measuring a line. So that's the actual length of the line, so there's no need to square. And that will bring us to the end of today and the end of the week. So again, as always, like, share, subscribe, and share with any friend, and turn on that notification if you haven't done yet. Until then, enjoy the rest of your day, enjoy your weekend, take care.